Now let's turn to talking about sequential games. Now remember, a sequential game is one where one player acts first, is observed, and then the second player acts. Remember, the grand majority of games that we're used to seeing and thinking about are sequential in some way. So, for example, if we play checkers or chess or Monopoly, all of these are sequential games where one player acts, is observed, and then other players act. Now, it is possible to have a sequential game that's a little bit more complicated, where, say, two players act at once during one round, and then they observe what happened in round one, and then both players act again in the second round. That is possible. The important thing that makes the game sequential is that there's an opportunity for players to respond to each other. Right, there is some kind of sequence that plays out. Now, in order to solve these games, we need to use what we call backward induction. Here, in effect, what we're doing is thinking out the end game, and then that thinking determines how we play the early game. One case of this is what we call the repeated prisoner's dilemma. Here what we're doing is we're taking the logic of the original prisoner's dilemma, and we're twisting it a bit by saying, well, rather than player 1 and player 2 playing this game just once, they're going to repeat it some number of times, perhaps infinitely. This then creates the possibility for them to play some kind of trigger, punishment, reward kind of strategy. Right? So player 1 may start playing in a way that says, well, rather than playing A all the time or B all the time, I will play A if you did certain things in the previous round. Right? Or if you've played every single round, if you play nice with me, then I will play nice with you. Whereas I'm going to punish you if you start playing more mean. Right? So let's start by thinking about how this would affect things. Right? Now, one strategy that's out there that ends up doing extremely well in these repeated prisoner's dilemmas is the tit-for-tat strategy. Tit-for-tat basically plays out as whatever you do in round 1, I'll do to you in round 2. And vice versa. I expect that you're going to, in turn, pay me back for what I've done to you in the past. Now, it ends up that this strategy does extremely well, and it's a remarkably simple strategy. In some ways, one might actually say that the golden rule, right, do unto others as you would have them do unto you, is kind of a version of tit-for-tat that's forward-looking rather than backward-looking. Right, so let's see how this plays out. Right, so after the first round, what happens in this game is determined every round after that by what happened in the first round. So suppose that we start out, as is the case in, say, the first table here, where player 1 and player 2 both play A in their first round. In that case, they will both play A in every round. Right? Each of them is playing tit-for-tat, so if you played A in round 1, I'll play A in round 2. If you played A in round 2, I'll play A in round 3, and so on. As a result, they both get 1 happiness point, or whatever we want to call this, 1 point in each round, for a total of 4 points over the course of, say, 4 rounds. Now, if we then think about, what about a different way of starting the game? Right, so player 1 might say, well, okay, that's the way I play if I'm playing mean, but maybe I should play nice. After all, if I play nice in round 1, that'll lead them to play nice in round 2. Right, so in that case, we would switch back and forth. So in round 1, playing B against player 2's A would not work very well for player 1. Right, they would end up with nothing from round 1. Well, player 2 would get 3 points. So this is a very good thing for player 2. But then come round 2, because of tit-for-tat, these two reverse. So now player 1 is playing A while player 2 plays B. So this is a good thing for player number 1. Then we switch it again in round 3, switch it again in round 4. Right, so we play it out over the course of, say, these 4 rounds, and we end up with a total outcome of 6 for each player. So it's a better outcome. Right, so player 1 then would say, well, if I start with A, and they're going to start with A, then we end up with 4 at the end. If I start with B while they start with A, as player 1, then I get 6. And since I really only care about my own income, or my own outcome, whatever, 6 is better than 4. So player 1 actually has an individual reason to go ahead and play B rather than A, which is very different from the one-round game. But then we go a step further and think about player 2. So player 1 has decided they're going to start with B. Player 2 says, well, if I start with A, then they're going to punish me for that in round 2 and in round 4. So I will end up with 6. Now, if I just start nice and I play B in the first round, while they're playing B in the first round, we'll play B every single round, right? Which means we'll end up with a total of 8. Well, 8 is better than 6, so I'm going to go ahead and start with B. Right, now what we notice here is that, if we recall, from the just one-round version of this game, both players play A. It's a prisoner's dilemma. They end up with this negative outcome, where each of them only gets 1, even though they could have each gotten 2. But by repeating the game, we end up with a totally different outcome. In fact, we've reversed the outcome. We've now created an incentive because of this possibility of being punished or rewarded for playing a certain way. We've created an incentive to play somewhat nicer. So one could actually think of a lot of human behavior in this way, right? That a lot of what I'm doing because I expect to be punished or rewarded later on. So really my life is not a one-round game. It's actually a repeated game. And as a result, we see most people tend to play the game relatively nicely. That is, most people are decent, stand-up human beings that are not necessarily out to hurt other people very much. Right? So, and a lot of this we can just explain simply by the expectation of punishments and rewards. Right? We expect to be rewarded if we play well. We expect to be punished if we don't. Right, so in the end, that's what ends up happening. We tend to play the game somewhat nicer. Now, one application of this repeated prisoner's dilemma is the World Trade Organization. So imagine we could boil down the World Trade Organization to just two institutions. Right? One is the US, the other is Mexico. And the US and Mexico are trying to decide what they're going to do with their trade policy. Right? So you could either adopt a protectionist trade policy or a free trade policy. Now, the way I put the numbers in here is really based on the politics of it. So the US thinks, well, if we protect, while at the same time Mexico has free trade, that's a very good thing for the US, because the US can export all kinds of goods to Mexico. At the same time, we don't have to worry about competing with Mexican products here in our home market. So businesses are happy, the workers for these businesses are happy, and in the end, it's a good political thing. Right. Well, the worst case scenario, as far as the U.S. is concerned, is if the U.S. has free trade while Mexico is protectionist. In that case, the U.S. has a bunch of Mexican products here they have to compete with, while at the same time, the U.S. doesn't have access to the Mexican market. That's a bad thing for creating jobs and businesses here in the U.S. So that would be given 1 point rather than 4. Now, when it comes to both of us protecting or both of us having free trade, we do recognize that there is, in the end, more benefit to free trade than harm, and that opening up this additional market is a good thing, and also having some Mexican products here is actually a good thing. After all, our consumers may like them, may want to buy them. So on the whole, if we both have free trade, that is better for the U.S. than if we both protect. Mexico has exactly the same incentives. They would love to be protectionist while the U.S. has free trade. At the same time, they recognize that everyone being free trade is better than everyone protecting. Now, if we play this as a one-round game, we end up with the outcome that both of them are going to protect. The U.S. says, well, if Mexico has free trade, it's better for us to be protectionist. If Mexico has protection, then the U.S. should also be protectionist. Right, so there's this very strong incentive for the U.S. and Mexico to both protect, despite the fact that a better outcome would be if they both had free trade. Now, the structure of the WTO is really to step into this conflict and say, wait, now we all know it would be better if we all had free trade. So let's find a way to make that happen. Right, so the WTO structure is set up in such a way that we have multiple rounds of trade negotiations, where all of us get together and are forming our trade policy together, rather than doing it separately. That is one thing. So we get kind of this repeated game going, where each of us is playing the game multiple times, right, and it's repeating on a relatively regular basis. At the same time, the WTO structure has a very explicit reward-punishment strategy built into it. That is, if I am protectionist, everyone else is allowed to be protectionist against me according to WTO rules. Whereas if I am not protectionist, if I have relatively free trade, then other countries are required to also have free trade with me. So there is no option for a country to be protectionist while others have free trade. That being the case, it really narrows our options down to either everyone protects or everyone has free trade. Given that choice, we're going to tend to see everyone have free trade, or at least we'll get closer there than if everyone protects. So this is one application of the repeated prisoner's dilemma to show that we might be able to get a better outcome if we can find some way to go and repeat the game and implement some kind of punishment reward strategy.